Hey there. This is the hopefully last video, at least the last video so far, of some of the steps we need to take for simulating random vibration for our CubeSat model in SolidWorks. One thing that I left out in the last video that I'll be showing in this video very quickly is how we're going to be modeling each of these bolt connections between the various parts, as we're using bolts to connect our parts together. And in the first tutorial, we just treated everything as globally bonded to each other. So the way that would extrapolate to the simulation is that if everything were welded together, that's how it would perform, which is not accurate. So this is the fun part where we get to go to every single one of these holes and do this exact same process. So for brevity of time, I'm going to just do 1 or 2 holes, and then I'm going to let you extrapolate to doing as many holes as are on the CubeSat that are connecting with each other, which is the key word. Don't like holes like this that aren't connecting to anything. Feel free to not worry about those. But the ones that have bolts in them, usually you can tell by the threaded part between the parts. We're going to have to do this process. So to do this, we're going to take the 2 parts and create, I think, what is it called? Projected curves on them. Well, first, select the first part you're going to need to do this process on by just right-clicking, hitting Edit Part. We're going to do a split line, that's right. So we're going to select the bottom of the surface, or the surface in which that's touching the part we're connecting to. So in this case, for the top part, we're selecting the bottom part. We're going to create a sketch on this, create a new sketch, don't edit another one. That's an important detail. Then we're going to create, if I can get the circle to pop up, there we go. We're going to create an area that models kind of the contact area of the bolt. So if we're using a 3mm bolt, the head itself, the socket head, is about 5.5 millimeters wide. And then shrinks down to the threaded part. So the difference between the 3 millimeters and the 5.5 millimeters is the surface area that's actually pushing the force down to connect the 2 parts. So we're going to model that here. So we'll create 2 circles, make the smallest one 3 millimeters. Actually, I stand corrected. So it looks like even though the bolt is 3 millimeters wide at the threads and about 5.5 millimeters the head, because tolerance, and we're making the holes 3.5 millimeters, so we have some slop, so we can line things up. We're going to want to make the inner hole size the size of this outer hole. So instead of dimensioning it, I can select my dimension tool. Sometimes it's a bit finicky. So I give it the ironic name of Solidworks. It doesn't sometimes. There we go. All right, delete that. I'm going to select this, select the inner hole, and we're going to select this inner hole. Select this, select co-radial, because if you ended up making it smaller than the hole, I think it ends up breaking the program when you try to do a surface split. So just make it as big as the inner hole. And then for the outer hole, we'll set it to 5.5 millimeters. Let's hit OK. Actually, I'll get to that in a sec. Actually, I'll just mention it now. If for whatever reason, some of these holes, when you make these projected curves, are going to be intersecting, or just are going, when you make them 5.5, are just going to be too big, and they may be in some of the open areas. In that case, just make this as small as possible so that the whole outer circle is completely within the bounds of your part. So for instance, let's see if I was using like 6mm bolts because I was crazy. And then I try to make, I think it's like 10 millimeters is how wide the outside are. If I did that, so you can see the outside parts of the bolt here are not fully contained within the part. So if I was using a 6mm bolt, I could adjust my fucking dimension. There we go. I would make this 6 millimeters just so it can just roughly do the contact bonding correctly. Because I found if you doesn't fully sit inside of it, you get problems. Just make the size fully fit in, and if it fully fits in at 6 millimeters for 3mm bolts, or whatever your head size that you're using in the future is, that's great. In this case, try to change this to 5.5, although, you know, it's mostly just getting the rough surface area correctly. But in our case, we're just going to try to keep attention to detail where we can. Okay, then we've exited the sketch, rebuild. We're going to go to features now. Now that we've created our sketch, we're going to select it, go to curves, split line, select the bottom face that we just created the sketch on, hit OK. Now we've made a split line for the first part that we're bonding to. Then we'll go to the other part we're going to create a split line with. We're going to create sketch, circle, make it as big as the inner one. So we'll go, actually instead of making it co-radial, we'll just set it to 2.5, call it good. Those are both the same thing. This guy will set to 5.5. Okay. Exit sketch. Oh, because I think this is a pattern part. Yeah, I'll ignore that for now. I'll troubleshoot. And I'll also make mention of troubleshooting parts later. But now, okay, we created sketch, created the reference, we made the curve. Now we create our split line, select the face, okay. The edit component. Let's see what breaks. All right, I'm going to ignore that for now because these are all hidden. Yeah, at least just for now. Okay, so you've created those sketches. One thing you will need to pay attention to, I don't know off the top of my head if which one of these holes I could do it to show this error. But sometimes as you're creating these split sketches or these split lines, because some of these parts are mated, like as the two holes are concentric with each other for the mating process, when you create this sketch, you'll create a conflict with the constraint. So then, you know, it's going to throw up the yellow box saying, hey, your constraint isn't defined anymore. As those constraint problems come up, exit out of the part and delete the problem constraint. And then, you know, when you delete like a concentric or a tangent, you can like click and move the part around and it'll be able to move everywhere. Redefine that constraint so it fits together and do it as soon as it breaks. Because what I've noticed is when I've gone through and did like 4 holes for multiple parts and then did like 8 holes for another, I was like, you know, constraints are building up. I'll get to that later. But then when you get to the later, you have like 20 constraints are all broken, and then as you drag the part around, everything's like moving everywhere. It's hard to try to remember where the holes lined up. So as you know, constraints break, try to fix those. In this case, it looks like it's just some undefined local pattern. So I'm going to ignore that for now. Yeah, because these are all bolt heads, it looks like, yeah. We're not actually modeling the bolts in our vibration test, so I'm just going to ignore that for now. But if you see anything that is constraint breaking, try to fix that as soon as it breaks. Yeah, that's going to be problematic. Okay, so what we just did for that hole, you get to do that for all these holes, and it's going to be fun, and you're going to hate it, especially whoever made all the holes. I'm not salty at all because I had to do this 3 times for 3 past cube sets, so yeah, you get to have fun as well. All right, so now let's say you've done this for all 60 bolts, the split line, and you're officially ready to just kill yourself. Hopefully not. That's pretty good, but you feel very disappointed. Now we're going to go into the model and start making the connections. So first thing we're going to do, if you've created global contact connections, delete those, say goodbye, because this process is just as tedious. Yes. Okay, cool. Now, for this next part, you're going to want to create an exploded view of your model, as this will make selecting kind of the inner parts easier. So we'll just go ahead and create an exploded view. Just drag all the parts off, as if they'll cooperate, that is. There we go. All right. Okay, that's one part. Switch to manual really quick. And Anyway, I'm not going to mess around with it, but basically you also want to get this magnet torquer part off as well, so you probably have to go into the subassembly there. Drag, clear selections, drag this guy out. What the fuck? It's an exploded view. There we go. All right. Sometimes it can be finicky, as we can tell. So just keep trying to brute force it, I guess. Okay, we've created an exploded view. You can see our beautiful little split line sketch here, which is what we want. You can see on that side. And now we get to do manual contact, or make manual connections to each of these little split lines. We're going to create rigid connections, as that's from talking to various people. That's the sort of connection these both will be doing. So in this case, we're going to select rigid connection, select our first split line, go to the other part, select the other face we're connecting to, select that, hit OK. And then when we look at it, we'll see the visual indication that these two parts are now bonded to each other. So now instead of this whole face being bonded to this whole face, these two parts are bonded around these small areas. So then when we actually random vibe it, you'll see these areas deflect a lot more than you would see them if you treated them as welded together. So yeah, that should be it's a quick tutorial. Hopefully that was moderately comprehensive. If you have any questions, if I'm still here, shoot me a message. Or shoot your team lead a message, more importantly. And if they don't know, hopefully somebody on the team still knows how to do Solidworks simulations. And if none of those works, talk to your simulation professors about how to make this work. Because that's how I had to do it, to figure out how to make this work. So yeah, hopefully that was helpful.